Hello everyone and welcome to this video which we will introduce in it the user-defined functions. So going to start with user-defined functions, what is the definition for it? So it's just a fragment of code that accepts 0 or more arguments, okay, and will give a certain result value and has 0 or more side effects. What the meaning of all of that? Like the user-defined function, it's like until now every code we are writing are just inside the main function, right? So what we are going to do now is just taking some details from the main function and putting it in a separate function, okay? This is why actually when we are dealing with functions, we will find that we are doing the following. One, hide details, right? Because you are taking some details from the main function and just put it in a separate function outside the main function, okay? Also to call the function more than one time. So for example, if the function is, let's say, calculating very complex equation, and this equation is calculated many times inside your code. So in this case, just put this complicated equation in a function, and every time you want to calculate new values with it, just call this function, will go directly to this complex equation and then calculate it there and return back the value and so on, okay? Also, there is another advantage of using user-defined functions, which is share with others. What the meaning of that? Yes, I can write a function and then put it in a separate file and then send it to someone else to use it. And something very similar to that is what you are using now, like when you are using string copy or string concatenate, or let even printf. All of these are already written functions, but they are embedded into your system, okay? But if you wrote your own function, you can just send it to someone to use it, right? So this is another advantage actually of using functions. So when we are dealing with functions, we name our program as structured programming. Why we are doing that? Because you are partitioning your program into different parts, right? Or let's say smaller parts, okay? If you are doing that, in this case, you are like changing the structure of your program. Instead of having just everything is written inside the main function, you just leave the main function for just calling the functions, and then the details of the functions are kept outside the main function. Okay, so how many functions you can use? You don't have like a limited number. Whatever number of functions you want to use, because every time inside the main function you are calling these functions, right? And then after calling the functions, the main function actually is going to solve the main problem that we have. Okay, so one very good advantage here is that functions separate the concept, which is what is done, from the implementation, how it is done. So let's say we are calculating the Euclidean distance, okay? And we will use an external function or user-defined function to calculate it. So the implementation, which is the equation itself for Euclidean distance, is done outside the main function, right? So how it is done, I will put it outside the main function. And then what is done here, actually the calculation of Euclidean distance is done, right? So this is how we get the advantage of functions. Also, using functions, this makes like the program will be much easier to understand. Why? Because you will just read the main function, right? And if you didn't know what this function is doing, actually you are going to go to the function directly and read it. If this detail is not like of your concern, in this case you will just read the main function and that's it. So in this case, the main function, instead of having a main function which is 300 lines, you may have the main function, which is 25 lines, right? And the remaining lines are kept outside the main function in the user-defined functions, okay? Okay, so as we said, there are some functions which are already embedded in your system, or let's say Segwin, when you are downloading it, they are downloaded automatically, like the math functions, the standard library, the string.h or string library, the C-type library, and so on. All of these are embedded already. On the other hand, you can write your own functions, right? So in this case, you can invent whatever function you want and then write it and call it from the main function. These are some examples of like the embedded functions that we have, and we must include the header, which like mainly defining all of these functions which are in a certain library. Okay, so how we can write functions? So remember with me, inside the main function, which let's say this is the main function, okay, you are having some declaration here, and then after that you are calling the function, okay? So how you call the function? You have here the function name, okay, and then the first argument and the second argument. What do you mean by the first argument and the second argument? And what do you mean actually by arguments? So any function, okay, is actually having some inputs to the function, and sometimes not having any input. So for example, if we are going to have a function, which we will do it with each other, to calculate the Euclidean distance, okay? So I know that if I want to calculate the Euclidean distance, I have to have x1, x2, y1, y2, right? So in this case, the function will have 4 inputs, x1, x2, y1, y2. So these are the input arguments to the function, okay? So in this case, here, I have my function is having 2 input arguments, argument 1, argument 2, okay? And then, after calling it from the main function, you have to define your function. So let's say this part is function definition. Okay, so you need to define your function. So you're going to say, okay, int the function name. So why I have here int? Because it's based on your function. Is your function returning a number? Is your function returning a double? Is your function returning a character? It's based on your function, right? So here, int the function name, and then int parameter 1, double parameter 2. What the meaning of that? Each parameter you have to specify its type. Is it a character? Is it an int? Is it a double? Whatever. You have to specify that in the definition. But if you are calling the function, you are just having here the argument and argument, right? But defining the function, you have to put each parameter, what is the type for this parameter, okay? And then after doing this, the only remaining step to write here whatever equation this function is implementing, okay? So I know it is not clear until now, and we will see an example to make everything clear. So before going to an example, just remember the return. So if you remember, sometimes I write void main, right? And then whatever code written here, and I'm done. And sometimes I write int main, okay, and some code here, and then returning 0, and I'm done. And every time at the beginning, when I told you, like, it doesn't matter, like writing void or int, that's totally fine. The only difference that here I'm not returning anything, here I'm returning 0, and that's it. And return 0 is just telling the compiler that everything is going right. So this, because like the main function we don't need to return from the main function to any other function anything, right? This is why it doesn't matter here. But it will matter in the user-defined function, because every function you are defining, either you are returning something from it to the main function, or let's say having just a printf function and printing something and that's it, right? So if you are returning something to the main function, in this case, your function must be int if you are returning int. It must be double if you are returning double. It must be char if you are returning a char, and so on. If you are not returning anything from your function, in this case your function must be void, which void here is saying that, hey, this function is not returning anything. So this is very important while you are dealing with user-defined functions. Okay, so here an example, starting with the header file, and then here, this is a very important step, which is declaring your function. Okay, so you start with declaring your function and then going to the main function. So one question here is, can I declare the function after the main function? And the simple answer is no. If you are going to use a function inside the main function, you have to declare it before it. You can declare and define the function before it, that's totally fine. But at least you have to declare it before the main function. So one question here is, let's say true or false, the main function must be the last function to be declared. And this is 100% right, because you have to declare every user-defined function before declaring the main function. Okay? So here in this program, I'm having the declaration of the function and then my main function and then calling the function here, right? Do nothing. And once you call the function, what will happen? Will happen the following actually, like the execution starts immediately after the main function. So every time the execution starts with the main function, right? And then we'll go to do nothing. We'll find that this is a function. Then we'll jump directly to the function. So once the compiler will find any function in the main function, we'll jump directly to it. So how the compiler knows that this function is there? Because actually this function was declared at the beginning. This is why the compiler knows that I have this function, and once the compiler read the function, we'll jump directly to the definition of the function. Okay? And then after jumping to the definition here, you will just go to execute whatever inside this function. Okay? And then after executing, you will return back from where you called the function and then go to the next line. And in this program, it's just return 0, so we are done, right? So it's very important to understand the sequence, how it is going, how I'm starting, okay? So I will start with the main function and then go to the function that I have to call and jumping directly to its definition, implement or execute any syntax there, and then returning back to the function call and going to the next line and so on. Okay, so let's do a hands-on example now, just to make things clear to us. So in this example, we want to write a function to calculate the square of any number. So the first thing actually to think about it, how I'm going to implement the function, right? So in this case, we want a function which will find the square of any number, right? So the equation is very clear. Equation is here x multiplied by x, for example, right? This is the square of any number. So you need to write a function which inside the function you will write this, okay? So the function definition will be as follows. Int, why I used int here with the function? Because this function actually will return an integer, right? Because the square, let's say 2 squared is 4, 3 squared is 9, and so on, right? So I know that I'm returning an integer. This is why I'm having int square. And then after that, your parameter, let's say here my parameter will be x, so I will have here int x, okay? And this will be the start of my function. And then after that, I will just go to right here, let's say int squared equals to, and I will go to implement this, right? Which is x multiplied by x. And finally, return what I have to return. I have to return squared, and let's close the function. So if you can see here, what I did is exactly the same what I'm doing with the main function. The only difference is that this is no more called the main function, right? And also I have an input argument, which we don't until now use with the main function. So int square, and then the parameter, which is x, the type of the parameter, which is int, and then I have here int squared, which like a dummy parameter or temporary parameter that I'm going to use it only to find the square and then return the square directly. Okay, there is another way actually to write this function, which somehow like an abstracted way of writing it. So I will write everything again. So here square and x, but instead of writing this line, what about writing this? Wow, it's much easier actually, right? I don't have to have a temporary variable or something. I will just return, you will give me input x, I will return x multiplied by x. And this is simply how you calculate the square of any number, right? So I think this is much easier for implementation. So let's try to implement this with each other now. So I will start here, let's say, if you remember with me, we always start with declaration of the function, right? You are going to use a function, which is a square function, so you have to declare it before the main function, right? So I want to declare it here, so I will just write the same thing, square, okay? And then this is declaration. After declaration, I will just go to my main function, int main. Oops. Okay. And then since I have int, I will have return 0 and close this one. And then what I have to do inside, so inside here, let's say I will say user num equals 5, or I can scan it from the user like externally, but that's fine. Here I'm just declaring a certain number, and then after that I will say int result equals to square of user num. So here what I did is just like declaring a new int variable, which is called result, and then calling the function, and its input argument is user num, which in this case is 5. Okay, and finally, just for looking at what already we have in the result, we will just print that, right? So the square number is %d/n, and finally I will write the variable name, which is result, right? Am I done now, or I still have one step? Yeah, I still have one step, which is writing the function. So I will go here and again put the declaration as it is, but this time I just want to definition. So here let's write let's write square function. Okay, so I have to define the function, and as we said, the easiest way to do it is just return x multiplied by x, and that's it. I'm done, right? based on that, I can just save, which let's name this as square, and let's go here and say GCC square and then square. Perfect, no errors. And then I will just run this and will give me the square number is 25. If I change it that to 3, my expected value is 9, right? So let's compile first and then run, and the expected number is 9. I said another thing here, that you can actually define your function at the beginning, and let's try that. So let's go here. Let me just make sure that I get this right. So I will take this from here and I will put here. Okay, so in this case, I went before the main function, declared and defined the function, right? So let's save and then run this without errors, and I got the right answer. So in this case, it is your preference if you want to declare the function first and then write its definition all the way down, or declare and write definition directly before the main function. If you asked me for my preference, I prefer to have the declaration of the function first and then put the definition down there. Why I'm doing that? Because it's very nice actually to look at the name of the functions at top. Like, okay, I have 3 functions, one is called square, one is called cube, one is called whatever, and then I'm going to the main function to see what is my program doing, and if I need more details about the functions, I will go down. This is why I prefer it. But if you are doing the definition directly before the main function, this means that you have to scroll down over each function, and then finally going to the main function to read the main function. If you want any information, you have to go back and see which function you want to look at, right? But again, this is your preference. So let me return it back to the way I prefer it, which is this one, and just to make sure that I returned everything right. Yes, okay. And hopefully this will give you some idea about functions. We will return back to visit functions like around 3 or 4 weeks later, just to see how we deal with functions in different ways and how we use pointers with functions.